We are in the second part of Chapter 14, and again, this is a kind of a diverse chapter. We're talking about tricks and gimmicks that microorganisms have, and I kind of outlined toxins for you. So let me lay out three different groups of toxins. Toxins are poisons. They're made by a wide variety of organisms. They may be fungi, they can be algae, they can be bacteria. Let me take you over to a couple of websites here. Alright, so here's a look at mushroom toxicity. They're obviously fungi. And I wanted you to note, this is a medical website, by the way, the variation of symptoms that you find with mushroom toxicity. Everything from lack of oxygen, which is cyanosis, to flushing, to liver damage, fever. Mydriasis is enlarged pupils, a low heartbeat, bradycardia, and then there are a variety of CNS symptomologies. Some mushroom toxins produce hallucinations, convulsions, some death. So it kind of spans the whole variety of symptoms. Then another type of toxin made by fungi, aflatoxins. This comes from Aspergillus flavus. You can see the Aspergillus mushrooms, Aspergillus mold up at the top, seen with scanning EM. It's very often associated with foods, particularly grains, peanuts, corn, wheat, and as you can see, here's where you find it. So anytime there's a lot of moisture in the soil, not the soil, but in the stored grains or peanuts, the mold, which is a common soil organism, will start growing and making these toxins. And then when they're ingested by animals, by fowl, by humans, we get aflatoxin poisoning. Then let me show you some algal toxins. This is about algal blooms. That's overgrowth of algae in ocean water. Also, they're in fresh water too. And they very often produce toxins. They can produce death of fish and other organisms. And again, when humans eat fish which have algal toxins in them, we can get anything from diarrheal diseases to neurological symptoms to death. Most of the algal toxin diseases are not deadly, but a few are, particularly if you get a pretty good dose. For example, here's one they're talking about, which is paralytic shellfish poisoning. Then bacterial toxins. You've all heard of the very pathogenic E. coli. It's strain 0157, and it produces a very potent toxin called a Shiga toxin, which is a protein toxin that's excreted away from the cell, and it's got a very high mortality rate associated with it. And again, symptoms ranging from intestinal disease to kidney failure. So there's kind of a introduction to the toxins. Let me back up and go over this way. Okay, so I'm going to dwell on the bacterial toxins because they're the major ones that affect us. So we have two types. We have endotoxins and exotoxins. So let me start with endotoxins. Let me take you back to the gram-negative bacteria, back in something like Chapter 3. And in the gram-negative bacteria, they have a very thin PG, peptidoglycan layer of their wall. But outside of that, they have a layer, which is also part of their wall, but it's on the outside of the PG. It's called lipopolysaccharide. and the toxic component of it is called lipid A. Gram-positives don't have this layer. Well, the other term for LPS, for lipopolysaccharide, is endotoxin. That is the actual toxin. It is part of their cell wall. All of the gram-negatives have it. This toxin increases as the bacterium increases in numbers. Usually it doesn't cause a big problem, but when the bacteria start to die, particularly if you give an antibiotic to purposely cause their death, when the bacteria die, their toxin is released from the wall as the wall disintegrates, and it causes the symptoms. Symptoms of endotoxin poisoning can be fever, drop in blood pressure, rash, kidney damage. It can be very, very severe. Now, the other toxin is an exotoxin, and it's a protein toxin, whereas the other is a lipid and a polysaccharide. So this is an excreted toxin. It's made by the bacteria. It goes out of the cell. Since it's a protein, if you heat it, it can be denatured and broken down. So it's heat sensitive. Endotoxins are not. Endotoxins are not as virulent, disease-causing that is, as exotoxins. They're hundreds and hundreds of times less potent. So a very tiny amount of an exotoxin can cause death. Endotoxins you need a lot of to cause death. Immunogenicity. Exotoxins can lose their potency over time, or they can be manipulated to lose their potency. And in fact, they are purposefully treated this way to lose their potency to be turned into vaccines. They are then called toxoids. And there are a couple of vaccines which are toxoid vaccines. The diphtheria vaccine and the tetanus vaccine are both toxoid vaccines. So these are vaccines made of the exotoxin, which has been deactivated, but it is still antigenic and turns your immune system on against it. Endotoxins, no successful vaccines. You can't turn endotoxin into a immunogenic toxoid. Incubation period. Exotoxins, remember, are potent at very tiny amounts, which means their symptoms come on much quicker. Endotoxins slower, and if you're asking what's quick, what's not, we're talking about as little as maybe a few hours in the case of a staph exotoxin poisoning, versus something like typhoid fever, which can be a couple of weeks. That's an endotoxin type of poisoning. The target sites depends on the type of toxin, particularly for exotoxins. There are neurotoxins, which are exotoxins. They produce neurological effects. There are cardiotoxins that affect the heart. There are cytotoxins that affect cells. So they have a wide variety of types of effects depending on where the toxin is located. Representatives. The exotoxin producers are generally gram-positives, Staphylococcus, Streptococcus, Clostridium, Bacillus, Corynebacterium. So those are the organisms that cause toxic shock syndrome, the intense rashes and the skin sloughing off the body that you find with flesh-eating bacteria, anthrax, tetanus, diphtheria, botulism. Those are all gram-positive diseases. There are a few gram-negatives that produce exotoxins, along with endotoxins, because remember, the endotoxin is actually the LPS, which all gram-negatives have. So if you're gram-negative and you make an exotoxin, you've got a dual toxin set of gimmicks. Those organisms that make exotoxins, example would be, here's some examples of toxins. Look at Vibrio cholera. It's about fifth one down. It makes both its own lipopolysaccharide endotoxin, and a very potent exotoxin. E. coli, the enteropathogenic 0157 strain, does both. The ch14 is an exotoxin, plus they have their own LPS. So these are really super pathogenic microorganisms that can make both. You also see some different other types of microorganisms and their toxins, some gram-positive, some gram-negative, plus you see a couple of fungal toxins down at the bottom. And again, different kinds of names of the toxins depending on where they act and their action. And here's kind of a comparison side by side. You can sit and look at this in more detail. But again, I have gone over this in a little bit of detail already. So you've got protein toxin versus LPS. The exotoxins tend to be very specific depending on where they affect, whereas endotoxins are pretty general. Toxicity for the exotoxins, highly toxic. Endotoxins, not so much. Immunogenicity, highly immunogenic. And again, you can turn it into a toxoid vaccine. Endotoxins, not so. So there's kind of a comparison of them. All right, so let's move into stages of a disease. You're looking at the progress of a disease over time. So look at that dotted line in black at the bottom. Below it, asymptomatic. Above it, symptomatic. And the more up the y-axis you go, the more symptomatic it is. So right away you should be able to tell that the incubation period is the time between infection and the beginning of symptoms. It's asymptomatic. The organism is colonizing, beginning to grow, finding its way into niches, kind of skirting around host defenses. The prodromal period. The beginning of symptoms, vague symptoms. They don't alert the doctor. They don't even alert the patient. The patient probably wouldn't even go to the doctor. In fact, generally, you're probably not going to the doctor until you get somewhere between acute and prodromal, or maybe even acute if you didn't have health care insurance and you didn't want to alert anybody until you were really sick. So acute is the time of most severe symptoms. Then there are two ways to go. One is the symptoms become worse, and now you're dead. That's not generally the case. Usually your immune system has kicked in sometime during this period of time, and your immune system starts to fight back, and the disease starts to be contained, and you go in the convalescent period. So again, 4 stages of disease: incubation, prodromal, acute, and convalescent. By the way, not all diseases have this identical progression set of stages, and I'll give you some examples when we get into class.